I am studying at Gebze Technical University, Department of Material Science and Engineering. I am a second-year student. I have been working as a secretary at EUROAVIA Kocaeli, of which I have been a member for 2 years. We are on the second day of International Space Symposium organized jointly by AIT Istanbul, AIT Ankara, and AIT Kocaeli. We will be with you with valuable speakers and productive topics. I will present today's program. At 2 p.m. UTC, Ahmet Karademir will be with us with the subject of contribution to achievements and developments in the space industry with Turkish Aerospace, moderated by Amir Hossein. At 3:30 p.m. UTC, Umut Yıldız will be with us with the theme of Universe in the Sandbox, moderated by Gülcenaz Baygeldi. Emre Havzalı will be with us at 5 p.m. UTC with the subject of the observation studies in Earth Science, moderated by Elif Güney. We wish you a pleasant and productive event. I leave the word to Amir Hossein.
Thank you, Dilara. Hello, everyone. My name is Amir Hossein Gordvagli. I'm a third-year aerospace engineering student at Middle East Technical University. I'm also a fresh member of EUROAVIA IS Ankara. Today, Mr. Ahmet Karademir is with us. He is an Earth Observation and Reconnaissance Satellite Program Manager and is currently working for Turkish Aerospace Industries or TUSAŞ. Thank you, Mr. Karademir, for being with us. How are you today? Can you hear us clearly?
Yes, Amir, I can hear you.
Great. At first, Mr. Karademir is going to deliver a presentation on the contribution to achievements and developments in the space industry by Turkish Aerospace. And afterwards, we are going to have a question and answer session with him. So you may write down your questions here in the comments section. Without further ado, I would like to give you the floor, Mr. Karademir. You may proceed as you wish.
Thank you, Amir. Thank you for the nice and kind presentation. Hi, everyone. As Amir presented, my name is Ahmet Karademir. I work as a Earth Observation and Reconnaissance Satellites Program Manager at Turkish Aerospace. So, and I would also like to thank you, before I start my presentation, I would also like to thank you to EUROAVIA Istanbul, Ankara, Kocaeli branches for this kind invitation to this event. Okay, I'll share my screen. Please confirm, is everything fine? Okay, hold on, please.
Yes,
can you
we
see
can
my
see your
presentation?
screen. Yes, we can.
Okay. Okay. I've been working in aerospace and the defense industry 25 years. And 1/3 of this experience, about 8 years, I've been in the space industry. Okay. And I will try to present you today the achievements that we had so far in more than 20 years. So I would like to take your attention to the title of the presentation, the contribution to achievements and development in the space industry by Turkish Aerospace. This is not just a humble expression of what Turkish Aerospace did up to now. It's just try to take your attention that space systems demand high technology, high quality, and a high cost. So this which require a spirit of collaboration. So we are proud of being this collaboration. So I will try to as much as possible to present this experience to you. Okay. So before starting this contribution of Turkish Airspace in the space industry, I would like to give a brief corporate introduction, starting with the history of Turkish Aerospace. In fact, TUSAŞ incepted in 1974, which is one of the shareholders of Turkish Airspace. The basic idea is the reduce the dependency of foreign dependency of Turkish military and aviation to the foreign dependency. So that's why they at that time the government decided to incept Turkish TUSAŞ, and afterwards, 1984, decision was taken to build F-16s as Turkish aircraft, fighter aircraft, and then namely Turkish Airspace, Turkish and the United States joint investment company, Turkish Aerospace Industries, is established. Okay, so the main goal of this company is to produce F-16s for 25 years, but it doesn't take so much time. So I joined the company in 1998, and then in 1999, as far as I remember, this was the last F-16 from the line, and then the company its own. Okay, so then I was the member of the first design and engineering team of 15 engineers at that time, and then we really at that time started to build our in fact make our own planes. Maybe most of you won't remember, in beginning of 1980s, it was the motto, make your own plane. At that time it was designed to build. So F-16 was originally designed by Lockheed Martin, and we built those aircraft here. And then after beginning of 2000, we were the design engineers to design and build our own aircraft. So the company merged, TUSAŞ and TIA merged in 2005. Now it's called TUSAŞ or Turkish Aerospace. Now we are proud of being and working on our indigenous products. Yes, the company, most of you know, but I just want to remind again, the company is the main campus is located in Ankara, Kahramanmaraş. It's a huge area, 4 million squares area, and with a state-of-the-art facility, about 640,000 meters square on the roof. Okay, in fact, when I joined the company, it was originally the factory just to build F-16, and we had a lot of in the recent years a lot of buildings established, and a lot of infrastructure is gained by Turkish Aerospace. I want to focus on, rather than all big facilities, state-of-the-art machinery, high technology and equipment that enables design, manufacturing and modernization of aircraft, aerospace platforms. I would like to focus on the Space One. So Space System Engineering Center is located here. In fact, the motorway is here. Maybe most of you maybe recognize on the way. And the AIT Center is located in the middle of the area. So I will give all this explanation I will introduce you about these infrastructures later on. So the subsidiaries, Turkish Airspace is not located only in Ankara. It functions in a lot of universities, Technopolis, and Middle East Technical, Yıldız, Uludağ, Technopark Istanbul, Istanbul Technical University, and Hacettepe University. We have lots of subsidiaries, but I would like to concentrate. Just to point out, C2 Tech is an electronics company, communication equipment on space, and the GSATCOM, which is our recent subsidiary, which is a joint venture company, Turkish Airspace and the INBA Argentine company. I will mention about this. Yes, when we look into this slide, our human resources, yes, the number of employees increased and ramp up in the recent years. When I first joined the company, as far as I remember, we were about 2012, 2,200, something like that. Even I remember after the F-16, we have dropped to about 1,800. Now we have 11,000, almost 2,000, so 12,000 employees. And as I said at the beginning, I was the member of 50, around the 50 engineers. So now it's about 5,000 engineers. And we have lots of intern engineers, and we have intern engineering agreement with a lot of universities. And most of the engineers have master's degrees, and some also have PhDs. Okay. Among the top 100 global players in aviation and space industry, Turkish Aerospace product portfolio, in fact, something happened. Product portfolio is in fact grouped in 5 categories: aircraft, helicopter, unmanned air systems, space, and aerostructures. If I will say about a business point of view, in fact, we have a vice president level 6 group, multi-mission, Turkish fighter aircraft is another separate group at the business center. And supporting the Turkish Aerospace vision, which is becoming a world brand aerospace company, Turkish Airspace also takes an essential role in space systems, and we have participated in national and international space programs as a prime contractor or a risk-sharing partner. Since 2002, we focused on a sustainable growth in the satellite market, on which group Earth observation reconnaissance satellites and communication satellites, and recently, we had a very high state-of-the-art, first and only fully equipped satellite AIT Center. In fact, I'm in charge of this branch, Earth observation and the Göktürk series DOPS satellites, and we will go through all these satellites in the following slides. Okay, before going through each satellite, Turkish Aerospace contribution to the space industry, I would like to give you a brief introduction of Turkey's space heritage, which I said already more than 20 years. And the journey starts with the communication satellites and Turksat communication satellites. The first one, Turksat 1B, is launched in 1994. And following the next communication satellites, 1996 and 2001, Turksat 1C and 2A. As you may guess, these satellites are, in fact, since the Turksat is a satellite operator, these satellites are designed and built by foreign companies. So Turkish participation, Turkish local participation has not started yet. And the beginning of 2000, I think what I would say is about the formal name of TÜBİTAK Space, TÜBİTAK Biltan, which is Information Technologies Electronic Research Institute, which is established in 1995. And this institute focused on, starting in 2001, focused on satellite. So BILSAT, in fact, is the first Earth observation satellite designed and built by Turkey. It is a collaboration by a foreign company, but it was the first satellite. Now it's not operational. Afterwards, Turksat, another communication satellite, launched in 2008, and following that, the second Earth observation satellite, 2011 RASAT, again by TÜBİTAK Biltan, designed and built by TÜBİTAK Biltan, launched. In this satellite, the participation and the local content increased. Finally, starting in 2007, Turkish Aerospace and TÜBİTAK Space team up, and they team up under the project Göktürk 2, and this satellite is launched in 2012, and it is Turkish first high-resolution satellite. Following other satellites is Turksat 4A and B, and then Turkish first very high resolution Göktürk 1 electro-optical satellite is launched in 2016. And very recently, 2021, 5A and 5B has been launched. So these are at the moment starting from Rasat. These satellites are operational in the space. So, and these communication and Earth observation satellites, these are the communication and Earth observation satellites of Turkey. So what is planned next? As you may guess, is a little bit, maybe it's very difficult to figure out at the first glance, but there is a gap between communication satellites are launched in a very how to understandable and reasonable intervals. But we were waiting for Earth observation satellites, and after Göktürk 2, which is launched in 2012, almost 10 years passed. So we haven't launched any on R, which is Turkish-built Earth observation satellite. So IMECE is planned to be the next satellite. TÜBİTAK Space is building it, and we are the satellite is currently under test at Turkish satellite AIT Center at Turkish Airspace, and Turksat 6A, which is going to be the first indigenous communication satellite, is planned to be launched in 2023. And SmallGEO, this is our aggressive introduction to the market, commercial market of telecommunication, which is currently designed and built by GSATCOM, Turkish Airspace. It's planned to be launched in 2025. And then we have some plans on small satellite constellation, but I want to focus your attention to Göktürk replacement, which is Göktürk, what we call is Göktürk yenileme. It is going to replace Göktürk 1, which is the first very high resolution of satellite, very high resolution satellite of Turkey, and we were planning to sustain this capability. And after that, most probably our first synthetic aperture radar, imaging radar, Göktürk 3 will be launched. And this is the journey, more than 20 years. And from now on, I will focus on Turkish Airspace contribution to this journey. Building expertise through which I mentioned in the roadmap, space heritage, and the beginning of my speech. Building experience through these Göktürk and communication satellite programs, Turkish Airspace built these capabilities, which are ECSS compliant, system engineering, spacecraft design analysis, which composed of structural and terminal control, subsystem, onboard data handling subsystem, attitude orbit control, propulsion, electrical power, and harness subsystems. These are we are capable of designing and analyzing those systems. And payload integration, definitely, both communication and electro-optical payload, and ground segment design, and space equipment, hardware development production, obviously flight software and ground software development, detailed part manufacturings and assembly for satellites, assembly and integration and test, launch campaigns and LEOP operation, in-orbit verification, communication, satellite operation and support. These are the capabilities that we built for the last 20 years, and this enables us to continue in this journey. Okay, I will go through I will go through the satellites that we built and that we participated in projects. In fact, these are the projects also, but I mentioned about the satellites, but these are all satellite system. I'll start with the Göktürk-1. Göktürk-1 is the first satellite of the series dubbed Göktürk. In fact, it was the first satellite, but it wasn't the first one launched, but it was launched in December anyway 2016. It was the contract awarded by Telespazio and subcontracted Thales Alenia Space. And this is the project of Presidency of Defense Industries, and the end user is the Turkish Air Force. And it is carrying a payload electro-optical camera and operating at an altitude approximately 700 kilometers. And it is the first high-resolution satellite which has a ground sampling distance of less than 1 meter. Turkish Airspace participated in this project in several work packages in design work packages in the space segment, in the ground segment, and also in the satellite operation and ILS work packages and the launch work packages. And more than that, not only design, we participate in the manufacturing parts of this satellite. This is the mission module structure of the satellite, which carry and holds the electro-optical imaging camera payload. So these mission module structure panels are designed and built in Turkish Aerospace. So this is, in fact, this is the first export by Turkish Aerospace or by Turkey into the space. And the satellite is in fact integrated, assembled, and integrated in Thales and Alenia Space premises, but it is fully tested at Turkish Aerospace, it's tested in AIT Center, and then it is packed and sent to the launch site from Turkish Aerospace. And you see the container, and then it is launched from French Guiana into 2016, and its expected lifetime is 7 years, but we expect this satellite will be operational until minimum 2026 or 27. These are the sample images which are available on the public from Göktürk-1. And this satellite is really state of the art, providing very high resolution imagery, and it is operational by Turkish Air Force. Yes, Göktürk-2. I mentioned about Göktürk-2. In fact, it is our first indigenous and high-resolution satellite. Turkish Aerospace and TÜBİTAK Space team up partnered under this project, Göktürk-2. Turkish Aerospace is responsible for structural thermal AOCS system and harness assembly, integration, and test of the satellite at our facilities. TÜBİTAK Space is responsible for onboard data handling and other equipment subsystems. So, in fact, this is again electro-optical camera. The payload is electro-optical imaging system, and it is a ground sampling distance of 2.5 meters. Its design lifetime is 5 years, but this satellite is launched in December 2012 and still operational. In fact, the satellite is planned as a research and development project, but it's used as operational by Turkish Air Force. Maybe at this point, I would like to state that TÜBİTAK Space is mainly involved in these R&D projects, but Turkish Airspace is involved in these operational satellite projects. And these are the sample images taken by Göktürk-2. which are available in the public. And Göktürk 3, it is the third satellite of the series. In fact, it is in line in my presentation because, in fact, Göktürk 3 is again awarded by Presidency of Defense Industries as Turkish Airspace as the prime contractor. It is initially planned as a two-phase program, and we have completed the phase one successfully in May 2016. It is the first indigenous synthetic aperture radar imaging satellite of Turkey, and this satellite would be a very nice satellite, but unfortunately, the second phase of the program has not been initiated because initially it was a reflector array, reflector antenna type radar, but and then the decision is to continue the program with active phase antenna. So in fact, the currently SSB, which is the President of Defense Industries, released the RFP, and we will continue the contract negotiations with the participation of local companies. And the local content in this satellite will be higher compared to the other satellites. And Aselsan, again, TÜBİTAK Space, TÜBİTAK Bilgem, SDT, and these are the local companies, and CTEC, and these are the local companies at the moment in Turkey, and we will be all partnering with them to develop this satellite. I mentioned about Göktürk replacement, which is going to sustain, in order to sustain the capability gained by Göktürk 1, this satellite is again planned by Presidency of Defense Industry. And the RFP is released in 2018, and we have been awarded the contract in last June 2021. So we are proud of being a prime contractor of this program, and this will really a big lab. It will be a big lab in the space industry. And I mentioned that Göktürk 1 has been designed and built by Thales and Space, and they based on the space heritage about 30 years. And this is going to be our really challenge for the Turkish industry to develop a very high resolution camera, a better capability than Göktürk 1. I cannot disclose all the details, but it's going to be better than Göktürk 1. And we're not going to be alone, as I said at the very beginning. Space systems, due to the nature of space systems, it requires spirit of collaboration. And when you reach to this stage and with a high resolution, very, very high resolution, you need more support with our local partners, local companies that I mentioned so far. We hope that we will be successful in this program, and it is planned to be launched in 2027. Before maybe they may operate for a while together before the lifetime of Göktürk 1 is over. So Earth observation satellites I mentioned so far, it's all up with Göktürk series. I didn't mention about the microsatellite constellation. We also have some plans. We are also planning to indigenously support microsatellite development, and also Presidency of Defense Industry has already released some RFPs which I cannot disclose. So unfortunately, what you have seen so far is that, I shouldn't say maybe unfortunately, but these Earth observation satellites are dominated by government, and that's why our efforts on the microsatellite and our upcoming efforts on the satellite, on the Earth observation segment, we would like to have more commercial, we would like to increase the commercial content like in the communication satellites. And I'm going to present the communication satellite. Turksat 6A is going to be the first indigenous communication satellite of Turkey. And the customer of this satellite is the Ministry of Transport and Infrastructure, Turksat, and the TÜBİTAK. This project is funded by them. And the contract is signed in 2014. And currently the satellite is under going through tests, and I'm going to present a video about it. So I'll move to that. Okay, so sorry, just a little bit. Yes, as you see, these are the partners, these are the customer, Turksat, Ministry of Defense, Ministry of Transport and Infrastructure, and Ministry of Technology, and Ministry of and TÜBİTAK, and TÜBİTAK Space, Turkish Airspace, Aselsan, and C2 Tech. They are the partners in this program. At Turkish Aerospace, we are responsible for structural thermal control system and propulsion subsystem harness and manufacturing of those parts at Turkish Aerospace. And you see the Turkish Airspace manufacturing these panels. I mean, communication satellites are big compared to the Earth observation satellite. This satellite is a approximately 4-ton satellite. So Earth observation satellites like Göktürk Yenileme or Göktürk 1, they are around 1 ton. So this satellite has big panels. And this is the central cylinder which holds the main structure of the bus. As you see, in 2017, the assembling of the Turksat 6A started. And in fact, it's the right point to mention about the satellite development. Satellite development satellites are developed and verified with models. There's a model philosophy. The first model is the structural and thermal qualification model, and then it is the qualification model, and then there might be engineering model or the qualification model, and then the flight model is the last model, which is going to be the launch. So before the satellite is launched, at most extent we try to verify its performance in the space by these qualification models. So you're currently watching the structural and thermal qualification model of Turksat 6A. as you see here, some of the panels are blank, and some of the panels have their equipment on it. So what we call as equip panels. So some equipments are installed on it, pre-installed on it, and they're assembled on the structure. So, oh, sorry. Oh. I think the video is frozen. Can you see?
Yes, we can see your screen.
Oh, sorry. Something went wrong. Sorry, I have to close the PowerPoint. It gives me error. Sorry.
It's okay.
I will start sharing again. The video size is big, so cause an error. Okay, it was the point where I had the trouble with the video playing, and now the assembling of the satellite completed, and then we start the test, environmental test. First, the mass measurement. This is the, oh, why is it doing like that? I don't know. Anyway. Hold on. Okay. This is the acoustic test. Finally, the okay. Sorry for the disturbance while playing the video, but it is I specifically choose this video because it is very good to have a tangible and the operation and assembly of the satellite design, built, assembled, integrated, and tested TürkSat 6A. Currently, the engineering model is under test, and then I think, and then the flight model will go under test. It's already manufactured and the parts and assembled, and then hopefully next year it's planned to be launched. And I want to go through next SmallGEO. It's the full electrical high throughput satellite. I mentioned at the beginning that this is our commercial satellite. We would like the new space trend in the Earth observation. There's also trend in the communication satellite. This satellite that you may figure out here around 1 ton or 0.5 ton to 2 ton satellite. So the satellites get smaller. It gives you flexibility for multi-launch configuration. And this satellite, in fact, designed by two companies, IMAP and Turkish Aerospace. The name of the company, as I mentioned, the joint venture company is GSATCom, and this is currently this satellite will provide a wide range of communication loads and different frequency bands and multi-mission, which will provide TV broadcasting, multimedia, and the internet access. And it will give you a lot of flexibility, and so we expect very good demand from the market for this satellite, and it's planned to be launched in 2025. We currently have a contract for this satellite from Argentine satellite operator, which we call as ARSAT SG1, second generator 1. I have another video related with SmallGEO, so please enjoy. So this is one of the advantages of this satellite. As you see here, it's stack configuration, and it fits on the stack and top of each other, sometimes next to each other, but usually like that. And it gives you the opportunity to very cost effective ride share launch configuration. So it is very modular design. I forgot to mention about this satellite. In fact, this is what is different from the other satellite communication satellites. It's full electric propulsion, so it is. That's why it is lighter. The Turksat 6A, for instance, is 4 tons. Is almost half of it is not half, but almost half. Ourselves is the fuel required for its operation, and it's for its positioning in the orbit. And Turksat 5A and 5B, they're also electrical propulsion satellites, but they are not ours. This one is designed and built by us. it will be placed at 36,000 kilometers. It will take more time to place these satellites in orbit, its operational orbit. As you well know, the launcher drops or injects somewhere, not at the 36,000 kilometers. So it's a transfer orbit. For instance, Turksat 5B, it's still transferring, as far as I know. 5A is operational now, but 5B is launched in December 2021, and it is still transferring to its orbit, operational orbit. And there's a high demand, high throughput broadband demand in the world due to the connectivity. So this satellite, we expect this satellite will have a lot of, will attract our customers. And we are doing a lot of marketing for this satellite, commercial marketing. And this satellite is a modular platform, and this and the platform could be used for other purposes like navigation satellites and some other purpose multi-mission. We can think about what we call this as a multi-mission platform. So SmallGEO platform is a multi-mission platform. Okay. Yes. Thanks for joint efforts by Turkish Airspace and the INVAP under the roof of GSATCOM, and we have achieved our first satellite system export of Turkey, ARSAT SG-1 of this satellite, and it is the start is going to design phases. So that's it for the communication satellites. As being aware of its primary role in the space industry, Turkish Airspace, in order to carry out sustainable technology management and sustainable growth in the market, we design our own satellite equipment and the software. It is quite critical, as you may also know from the aviation platform, aircrafts, and the equipment and some critical equipment. Those platforms carry some critical equipment and the software which foreign companies reluctant to share. So what we did, we've been developing our onboard computer for a while, and we're going to install this computer and its associated flight software on our Göktürk replacement Göktürk Yenileme satellite. So our satellites, our Earth observation satellites, will fly our own computer and the software. Another equipment on the Earth observation side is a platform interface unit. Our activities are going, it is less mature compared to the onboard computer, but this equipment is also critical. It gives this equipment interfaces with all subsystems, different subsystem interfaces in the satellite, and connected through a bus 1553 or other could be for the onboard computer. So that's why it's called a very platform dependent unit, but it usually goes through a lot of customization. That's why this is one of our target equipment which we would like to do in a house. Another two equipment underneath, power control and power distribution units. We intend to develop these equipment for the communication satellites. These are heavy and powerful equipment, especially for the communication satellites. And these two equipment is under development. Obviously, we are not on the only on the space segment. On the ground segment, we have already developed ground command and control software for satellite independent part. Satellite dependent part is being under development for Göktürk Yenileme satellite, our first very high resolution Earth observation satellite. So now we come to the Space Systems Assembly Integration and Test Center. Yes, this is our center. This center is established as part of the Göktürk 1 satellite development project by the support of TürkSat and Presidency Defense Industry Project, SSB Defense Industry Project. So this center presents really a good capability. Among only a few developed countries in the world have this capability. It is the first and only fully equipped satellite AIT center in Turkey, obviously, and in our neighborhood region, especially in the East or Middle East neighborhoods. And it is around 2,800 meters square closed on the roof. And you see the overview of inside of this AIT center. And it is class 100,000 class as AIT center. In some parts and with the special equipment, we can achieve a better class category. You can assemble, integrate, and test up to 5 tons of satellites at the same time with LEO and GEO satellites. I would say about 3 satellites can be assembled. Currently, I showed the video for the TürkSat 6A, and imagery is here. Currently, 2 satellites are inside in this AIT center. This center provides a capability for vacuum thermal vacuum test, vibration test. I showed the video in the video, acoustic test, and mass properties measurement, and EMI/EMC test, compact antenna test, and mechanical ground support equipment. And also it has inside, it has a multi-layer insulation, which you see usually the yellow stuff, a blanket covered to control the thermal control of the satellite. We have a workshop. We also have capability to design and manufacture MLI inside AIT Center, and we also have a harness workshop for the satellite harness. So this satellite, we are proud of this satellite. It is really a good capability. And we also have other infrastructures. This satellite is designed for big satellites. As I mentioned, Göktürk 1 is tested in the satellite. TürkSat 6A is being under test. It's a big vacuum test. Göktürk 2, at that time, between the years 2007 and 2012, we assembled, integrated, and test in another facility at our premises. The diameter of the vacuum chamber over there at that facility is 4 meters. We also have small thermal vacuum tests for our equipment. We design like onboard computer. We test their vacuum tests. We perform its thermal test in this small thermal vacuum test. We also have hardware design and development laboratory where we manufacture parts, and they're going to be tests and the vibration and combined temperature and kilometer tests of this equipment can be performed at our facility. And for the satellite integration and system level integration and software integration is being performed at Satellite Integration Test Laboratory. These are And what we all mention about is the space segment. And usually the ground segment is overlooked, but thanks to Go to One project, we also have a proven experience on the ground segment, satellite ground segment design and satellite operations. So we have participated the LEOP and launch activities of Go to One. You see the team here is a very good memory, and after its launch and its verification, during its verification in the orbit Go to One, we all participated. Even after the commissioning phase, 2 years guarantee phase started, and Turkish Airspace ground team provides a technical support. Not only maintenance and operation, we provide a technical support for this satellite. So it is 7 days, 24 hours operation support. And currently our team is the guarantee phase completed and the maintenance phase of the program started, and our team is there still providing 24 hours, 7-day support and the flight dynamics support. For instance, we're participating, we're analyzing collision avoidance and maneuvering. We plan a maneuvering for this satellite, and obviously consult the original manufacturers and the customer. And this is very important. We also perform frequency coordination, and Presidency of Defense Industry consult us for international frequency coordination. And we have some efforts for the image processing enhancement, specifically for the Go-to yenileme. We will, as you may guess, for the very high resolution satellite imagery, we have to have this capability. Okay, and the user segment and for the dissemination and also archiving of these images, we are going to partner with SDD company, and we're working with them. And with the finally with the Go-to yenileme satellite system from end to end, Turkish Airspace and its local partners companies, Aselsan, TÜBİTAK Space, C2Tech, SDT, TÜBİTAK Bilkem. We will have all as Turkish companies, we will have all end-to-end capability for the satellite system. We're very proud of you. More than 20 years time, we have reached this point, and hopefully the satellite will be launched in 2027 and beginning of 2030s. We will be in a very good situation in the space industry. We will be competing with the world, both on the Earth observation and the communication satellites. Okay, the last video I shared is prepared by corporate relation and the career management team to motivate young talents to join us. As you may know from our website or from other events, We have very nice young talent programs to motivate undergraduate students. I mentioned about the spirit of collaboration at the beginning of my presentation, and I hope that this presentation and this is very useful for you, and it motivates you to join us. And I hope you will join us, and we will all together pave the way beyond the skies into the space in the following years. Thank you for your attention. This is all my presentation.
Thank you, Mr. Karademir. Now let us proceed with the question and answer session. So the first question is, do you think it is possible for Turkey to be one of the leading countries in the field of space in the near future? If possible, in how many years do you think this will happen?
Okay, it's a very nice question. In fact, it just reminded me what I forgot to mention. In fact, Turkey could be the one of the leading countries. I believe that, but it will be maybe sooner if, as I mentioned, if we did maybe we lost a little bit some years, in my opinion, for the last 10 years. It might be better if we haven't lost those years. But we will be the leading company because first is Göktürk 2 is launched in 2012, but in 2012 we haven't had any aircraft or our indigenous product in the sky yet. It's quite strange, isn't that? We have our first indigenous product in the space. So I believe it will happen in the next decade. We will be the leading country in both communication satellite and Earth observation satellite. But it needs more support. As I said, it requires space system requires high quality, high technology, high cost, but it also requires high skilled human resource. So it both and also a budget. It requires a budget and attention from both government and also the commercial side. If it happens and if we succeed in our projects, and we will continue and we will sustain in the market.
Thank you for your answer. So the next question is, while the aims of young people is to go abroad have increased tremendously, will sufficient infrastructure be provided for the development of the Turkish space industry?
Yes, we are also. I'm also very sorry about this. In the recent years, a lot of young talents went abroad, and as I mentioned in the One project, that also we participate in work packages, and some of those engineers also went abroad. But I said I presented Göktürk Yenileme. Göktürk Yenileme is a very high resolution satellite project. It is a very nice project. It gives it. If you want challenge, the challenge is here. Okay, so you don't need to go abroad, and we have those domestic capabilities in Turkey, and we are partnering the companies. I always stress the spirit of collaboration. Those companies are working together with Turkish Aerospace. Turkish Airspace acting as a prime contractor, but we are working with TÜBİTAK Space, SDT, Aselsan, C2 Tech. You may join those companies. You may join Turkish Airspace, and you may be part of this success. So I believe that there will be no more manpower loss in the space industry in the following years. So I believe when we progress in Göktürk Yenileme, we will take attraction of those people, and those engineers will come back.
Thank you for your answer. I believe the next question is the second part of the previous question. Uh, does Turkish Aerospace Industries conduct a special
Yes.
study for young engineers to provide this infrastructure?
Yes, I think I mentioned about this, and also I mentioned about Turkish Airspace Young Talent programs, and I recently learned that we have a very new program which is called Engineering Development Program. It gives you a flexibility undergraduates about when you're third class, and you can start, and they give you a project, and you can join, and you can do a pilot project, and it gives you a lot of opportunity, Turkish Airspace, to young talents. So they can contact me, and they can contact maybe they have their relatives or acquaintances, friends in the company. So we can support them, no problem.
Thank you for your answer again. And the next question is, I have heard that the reasons for not building a domestic launch pad were that it was not economically logical and the location of our country was not suitable. So does being dependent on foreign countries or private companies such as SpaceX cause problems such as privacy violations or technical problems in the future?
Yes, it's a very good question, but the question has its answer in it. Yes, as far as I know, I'm not an expert on launchers, but and also orbit mechanics. But anyway, the Turkish location is not suitable, as you may see. All the is not suitable, especially for the Earth observation satellites launching, and also for the communication satellites. And it's not economically, yes, because you might have a business line for this one, but we also have our own efforts. Maybe you heard of it, but we will build our own efforts for the microsatellite launching from by Roketsan. But this doesn't mean that it doesn't mean that the site will be located on Turkish airspace. But we started, so which means that for this kind of privacy issues, or which in case we might have some limitations by the launch companies and location sites, if we can build our own launcher, we might use, maybe in the future we might look for opportunities or our friendly countries. Even if Turkey is not suitable, we might look for locations on our friendly countries. But yes, launching is a very big problem and is a very big limitation side. For instance, with the Chinese and the states launchers, depending on the equipment that you use, it also limits even the design, even the selection of equipment during the design and development of the satellite. But currently, SpaceX provides very cost-effective launching opportunities, so it is really economical. Otherwise, a launch service procurement is the highest cost, one of the highest cost uh, item in the satellite system.
Thank you for your answer. I want to thank you, Mr. Kardemir, for honoring us with your presence today.
I would
Uh,
like to
I,
also thank you.
I give the floor to Dilara.
Thank you, Mr. Karademir, for his speech. We have a half-hour break. At 3:30 p.m., Umut Yıldız from NASA will be with us with the subject of Universe in Sandbox. See you in the next section. Bye-bye.
Okay, see you. Bye bye. Thank you.
Hello everyone, I'm Gülcanaz Baygeldi. I'm studying aerospace engineering at METÜ and it's my freshman year. I'm also a member of EUROAVIA IS Ankara. Today, Dr. Umut Yıldız is with us. Dr. Yıldız is working at Spectrum Engineering Group of Communication Architectures and Research Section of NASA's Jet Propulsion Laboratory, California Institute of Technology. Thank you for being with us, Umut Yıldız. How are you today? Can you hear us clearly? We are going to have a question and answer session with Umut Yıldız. So you may write down your questions in the comments. Do you have something to add, Mr. Umut Yıldız, before starting? Sorry, we cannot hear you.
How about now?
Yes,
How
it's
about
clear.
now? Okay, I'm fine. How about you?
I'm fine too. Is it morning in America now?
Yes, it's 8:31 a.m.
Okay, thank you to have us in your morning.
So I see some questions at the chat. Are they for me or for the previous speaker?
They're probably for the previous speaker, but we can put our questions after the first questions. You can see on the screen.
Okay, all right, okay.
So we can start with our first question. What does an astrophysicist do on an ordinary day at NASA?
Okay. So basically, NASA. Everybody thinks NASA is a big astronomy and astrophysics organization, but not at all. It's basically yes, there is a huge astrophysics section or astronomy section, but it's a huge engineering department as well. So what I would say is, for example, in JPL, so there are actually, okay, let's go back. So there are 11 NASA centers around United States, and Jet Propulsion Lab is one of them, and I'm in here as well. So in the in our campus, something like 6,500 people works here, and I think it's like a building, and just a few floors is full of astrophysicists. So it's not like there are a lot of astrophysicists at JPL, but it's mainly creating tools for the astrophysicists or for the scientists to do their science, especially the telescopes or some space missions in different planets, in Mars or or Jupiter or whatever. So right now we are working on Mars missions, and also the next mission is going to be the Europa mission, Europa Clipper mission. So this is the next big mission for us. So we are in JPL. We are creating tools for the scientists to do their research. So your question was, as an astrophysicist. Right now, I'm not working as an astrophysicist, by the way. So I did all my education on astronomy, my undergrad, master's, PhD, and postdoc on astrophysics. But in the end, I decided to change my career to space telecommunications. And since like 6 or almost 7 years now, I've been working on the telecommunications section of the Jet Propulsion Lab. So I only worked like 2.5 years at the astrophysics department, which was actually a nice experience. So we have some instruments or telescopes we could go. For example, there are telescopes in Chile or in Hawaii or in Arizona, or there's a airborne observatory called SOFIA. So yes, we have an access to those kind of telescopes as long as we write good proposals and we get data from there. And as an astrophysicist, once we get the data, we analyze this data and interpret the data to find out what we are trying to find out. So my topic is star formation. I wanted to find out how stars are formed, and how Earth forms, like Earth-like planets forms, and how life forms in the end. So these are big questions, and I was working on those kind of questions before. And rarely I also kind of work on these topics as well. Sometimes do the observations and work on the data as well. So yeah, this is kind of basically it.
Thank you so much. So we can continue with our next question. We have, here you can
yes,
see.
have you started to make observations with the Webb Space Telescope, James Webb Space Telescope? Not really. As far as I know, it is still in the commissioning phase. So what happens is you cannot directly start the telescopes once it's in space. You need to do a lot of testings. So it takes around 6 months, what they said. They can either finish it earlier or it takes much longer than that, but we will see. But normally what they said is that it will take around 6 months. So we are almost there, because it was launched in December, I think 25 on last year, 2021. And yeah, we are in April 10, right? So we have almost a month left to finish the commissioning phase. And right now they are possibly doing the test observations. For example, they have some sources that we know very well, okay? And we know that this source will create this kind of emission. We know it very well. That's why we want to observe this kind of sources first, and then check our previous measurements. If they are consistent, then we say, okay, it's James Webb is doing well, and then we proceed to the other observations, the new observations. So this is what we do. And right now I think we still have another month left, and then we will do the observations later.
Okay, and we have one more question connected to this one here.
Yes. What are the advantages of the Webb Space Telescope compared to the Hubble Space Telescope? Well, it's much bigger telescope. Hubble Space Telescope is a 2.4 meter space telescope, and James Webb Space Telescope is a 6.5 meter telescope. So basically, if you have a big collecting area, then you can see much further distances, right? So that's why the most important thing with the James Webb Space Telescope is it's in infrared, so it can go through dust, which is most important in this case. For example, imagine the optical telescope and infrared telescope. So optical telescope is like what we see with our eyes, right? I see you exactly like that, and this is your picture. But if I have an infrared camera in me, I would see the picture of you with the temperatures. For example, if your eyes are much hotter, then I would see like more redder, or if your nose is hotter, it's more red, and if your cheeks are like much colder, it's a bit bluer, or it's, if there is no heat, or not, it's not, we cannot say no heat. If it's much colder, then it would be much more towards the black color. So you will get a picture of your temperature. Okay, so with an infrared telescope, you could see the temperature of the regions as well, and you can see further if there is a dust in front of you. So that's why infrared telescope is much more important in this case, because we can see further, and also with a much bigger collecting area, like 6.5 meter mirror, then we can see much further away toward the Big Bang. So the Big Bang and the Big End is like Big Bang and the beginning of the universe and the end of the universe is kind of the same place. So you want to you have a telescope and you direct the telescope to the end of the universe, you actually see the beginning of the universe, the Big Bang, right? So with James Webb Space Telescope, we are going to see sometime after 200 million years the Big Bang. So which is really good, you know. And at that specific time, new stars are started to born, and we will see the first stars in there.
Yeah, sounds amazing. So we have
Yes, it will.
we can have some lucky connections with them. So our next question here.
While doing observations, have you encountered signals that are possible to be produced by intelligent forms? Well, if we would get these signals, you would hear it. You know, we cannot hide it. You know, and this is the biggest news ever. You know, if you want to be an astrophysicist, the most important discovery in your life could be the life detection, right? Basically it, you know. Well, so far nobody has seen these kind of signals that is coming from intelligent life. Well, we wish, but it doesn't happen. The reason is, with these kind of telescopes, what we see is the signature of some molecules and atoms. Okay, the molecules has a specific signature, and we have the telescope, and the telescopes are set to observe this kind of signatures. Okay, it's not like we specifically look for, you know, intelligent life signals. For example, we want to find out water molecule. Okay, water molecule has a specific frequency because it has a rotational transition. You are a physics student, and they have a rotational transition, and with the rotational transition, it creates some energy, and this energy corresponds to some frequency. For example, for water, it's 557 gigahertz. So if you have a telescope which is set to 557 gigahertz band, and then you set your you direct your telescope to a specific location, and if you see something, then you would get a signal, right? If there is water molecule in there, then you say you get the signal. If there is no water molecule, then you don't get signal. So this is basically it. So we specifically set our telescopes to specific frequencies of specific molecules. That's why we only get the signals from what we are looking for, not like signals of, you know, intelligent forms. That's why we get kind of we get kind of we only get science signals.
Okay, thank you. Here our next question.
What could JWST see through gravitational lensing? Will it ever use that technique? I'm not sure about that because I'm not working on gravitational lensing research. Well, basically, you know, we see gravitational lensing effects in towards galaxies, you know, that is far away as well. And yeah, I mean, this technique has been used many times with different kind of telescopes. So it's been used, and you know, it's been proved okay. But yeah, I'm sure JWST will see, but this is not my research.
Okay, thank you. After some theoretical questions, we see you a lot of events in Turkey's universities, and here is a question about this. They ask, is there anything you would do differently if you were a student now?
Oh, if I was a student now,
Yeah.
yeah, I okay. I loved astronomy. I still love astronomy. I wanted to become an astronomer since I was like a secondary school student. Okay, and I wanted to continue getting my education on astronomy. But right now, what I feel like is maybe I should also get some other fields. You know, I should also get the sense of other fields as well. What I mean is, for example, I did my undergrad in astronomy and my master's in astronomy, my PhD in astronomy. They were in different universities, but they were all in astronomy. What I would do differently is, if I would study astronomy or science, I would do engineering masters, and then I would continue doing astronomy PhD, so that I could expand my horizons. I could get more more experience on different levels. So yeah,
Sorry, sorry.
yeah.
So, as we are aerospace students, are we in the true way to be a successful astrophysics or astronomy person?
No, I mean, you started as an engineer,
Yeah,
and I mean, if you want to continue with a PhD, I would suggest maybe you do science as well. For example, in your masters, or there is double, what is it called? Double undergrad, or you study one field and then you also study another field. They, for example, what is it called in English in Turkey? Çift anadal.
Çift anadal program. Yes.
Yes, I don't know what do you call it in there. So you can get two diplomas, but the thing is, some of the students are doing like you know two similar fields. Okay,
Yeah.
they study two similar fields. For example, they do computer science and then they do electrical engineering, or computer engineering and electrical engineering. I mean, this is nonsense. Okay, this is good for you. You would get to engineering diplomas, but well, I would do, if you are doing computer engineering, and then the other one could be philosophy,
Yeah.
not related to that one, so that
For
you
example,
can, you broaden your horizon with that.
yeah, my dream is actually make a double major with history because I
Yes,
like
exactly.
history, and they
Exactly.
are not connected, but it sounds good for me.
Yes, exactly. If I would have a chance, I would study archaeology as well. Really, I
Yeah.
mean, I even right now I want to study archaeology. I can. I mean, I finished my PhD 10 years ago, but if I have time, I would study. I would start an undergrad at some, I don't know, in an American university here somewhere, and then start over archaeology department or philosophy department or something, like something very different. I mean, this is for your, with this you improve yourself, right? I mean, you make your decision when you were like 17, 18 years old, and you get into that, university, get into that department, but you have no idea if you will like it in the next 50 years, right?
Yeah.
So my recommendation is do something else as well. If you don't like one of them, you would follow the other direction. So that's
Yes.
why, I mean, people are saying, "Oh, this is an engineering department. This is an engineering program. You are, you should be really, really good in the future." No. Yes, you may earn money, but you may not like it.
And
So
also nowadays, I'm hearing some multidisciplinary study benefits. So
yes,
there also fits with this concept. So I agree with you, and I hope I will continue think like that and study like that. And
Yes,
I
you
guess,
should actually. You should.
yeah, we have some more questions about, again, theoretical and space.
Is there any edge or center of the universe? No, there is no center of the universe because the universe is expanding like a bubble. It just expands, but we don't know where the center is. Every galaxy goes away from you all the time, right? But the galaxies that are further from you goes much faster. And this is like a concept, like a balloon concept. There are dots in the balloon, and then you fill with air, and then the balloon just gets expanded, and the dots are galaxies in the universe, and the galaxies are just getting away from each other, so that there is no center. So this is kind of an example that we could give. And yes, that's why there is no center. And the edge of the universe is actually the Big Bang, if you mean that. So we, as I said, when we were discussing about the JWST telescope, we want to see the end of the universe. You have a huge collecting area, and you have a better electronics and everything, and you want to see what is further ahead. And what is further ahead is the Big Bang. So that's why the edge is the Big Bang, and we can see the cosmic microwave background, which is 280,000 years after the Big Bang, and we have a lot of nice pictures nowadays. But besides that, like the new stars, we still need to get JWST working right now.
Okay, and we have a long question now. You can see.
Is we just accept the existence of dark matter? Well, you choose not to accept because we cannot explain the orbiting speeds of some stars and galaxies. How can we prove that dark matter exists rather than its effects? Can we just wrong about this concept? Yes, we can be wrong about this concept as well. So the idea is, as it was asked in the question, the existence of dark matter was discovered by the rotational speeds of the galaxies, because the stars in the galaxies are rotating like a wheel, normally like in the solar system. So if there is sun in the center, and the Mercury, Venus, Earth, Mars, so Mercury rotates around the sun much faster, and then the other planets rotate much slower, revolve much slower. If you go further, it just goes much slower. So it takes many years for a planet away from the sun, right? So in that case, this is the Kepler's law. But when we look at the center of the galaxy, or when we look at the galaxy rotates like a wheel. So even though this is the center of the galaxy right now, even the star here and the star here rotates at the same speed. So it's like a wheel. That's why we think there is something in between these stars that we cannot see, and it makes the galaxy rotate like a wheel. And it's what we call it a dark matter. We don't know, we don't see, but we know the effect. It's there. Well, can we just wrong about this concept? Maybe we are wrong about this concept. Maybe there is another physics explanation that we have no idea right now. We could find out another physics explanation and explain it better. There's actually a called MOND theory, modified Newtonian dynamics. If someone is interested, you can search for it. MOND, modified Newtonian dynamics. So these people says say, well, we don't need a dark matter, or we don't need another kind of particle. It's just physics. We just need to play with physics, even Newtonian physics, and then understand why this behavior happens. Well, so far Mond theory is not very popular, but it is there. If you want to work on it, you can work on it. But well, it's dark matter seems like plausible explanation right now. And yes, we do that. We continue doing that. We continue searching for it.
Thank you. Sayonara has a question, asks, is this notion correct that universe has expanded and is dispersed in a relativity flat manner?
No, okay, there's a different concept that's I need to explain here. That the universe has expanded and it's dispersed in a relatively flat manner. No, the idea about this flat is the curvature of the universe. Okay, it's not about I wouldn't say it's not about. So okay, let's put the concept first. Flat universe means yes, what we found, the universe is flat. But what it means is you have two lasers, and you are an astronaut. You are in space, and you send one laser like to the end of the universe. Okay, you have a friend, another astronaut friend, and he has the laser too, and then he sends this laser to the end of the universe. So what would you expect if these two lasers are connecting, or doing like that, or just parallel to each other? So what we found is these lasers are kind of doing going parallel to each other. So that's why we call a flat universe. Okay, we are like 3D, the planets, the star, the galaxies are like 3D. How can the universe be flat? This is it. This is the explanation of the curvature. Actually, that's why we say the universe is flat. So that the universe is expanded and is dispersed. I mean, the question is ambiguous. I'm trying to understand what he means here. That's why the universe expands, yes, and is dispersed in a relatively flat manner. Yeah, I mean, if you mean that the universe is expanding in a flat, okay, yes. I mean, I am having hard time understanding this question. Universe is expanded and is dispersed in a relatively flat manner. It just expands in an accelerated universe. What we call an accelerated universe right now.
Maybe it's about they say every day the universe expands. Is it about this situation?
Yes, the universe expands. The universe expands. Actually, the universe expands. The universe is an accelerated expansion. So that means there is a dark energy component. So there's another concept here. Because it expands in a much faster speed right now. So there must be an energy getting in the equation. So we cannot see this energy. It's dark. So that's why it's called dark energy.
Okay. Barish has one more question. He asks, I know it's kind of theoretical, but if the black hole gets everything inside in its event horizon and doesn't give any information about them, where does this information go? And as information cannot be created nor destroyed, where does this information go? He asks.
Okay. Yeah, I'm not a black hole astrophysicist, but it's called an information theory. So it's basically basically we have to understand what an information means. Information is, for example, we have the atoms of, we have the particles and everything, and these particles has a location to make this, for example, this dongle happens, right? And the arrangement of the atoms to make this this is an information, okay?
Yeah.
And you can use these same atoms to make this, right? It's the same. It can be the same atoms, but the arrangement of the atoms and the particles are different. So the idea is this kind of information is stored in, for example, in here, but when you're close to a black hole, or actually inside the black hole, this information could be lost, okay? Because you are, black hole, it's everything,
Yeah.
it just sucks all the light, particles and everything. So the idea is the information can be eaten as well. We don't know about it yet. There are theories, of course. The information can get into the black hole, it can be fully lost, and it can be fully the information about the arrangement of the atoms are fully changed, or maybe the information about the arrangement of the atoms or particles are stored somewhere in a black hole. We don't know, we cannot see. It's like it's it's your hypothesis saying, like, as information cannot be created nor destroyed, where does this information go? Who said that? Okay, somebody said that in the beginning, but well, nobody knows what happens in the black holes.
Yeah.
There are only theories. Maybe information can be created inside the black hole, and new information can be created inside the black hole, or this information can be destroyed in the black hole. We don't know yet. So the physics laws that we see in our current universe does not have to apply inside the black hole as well, or another part of the universe. Maybe there's something that we don't know yet, has different physics.
Yeah, and
I mean,
probably, yeah.
imagine 100 years ago there was no black holes. Black hole theory was not there. 100 years ago, Einstein has this, general relativity in 1915, and then black holes actually the idea of the black holes started just 1 year after it. But even Einstein didn't believe in the black holes. Almost even he didn't even believe until he died. So 50 years ago, 100 years ago, there was no black hole theory. And maybe 50 years later or 100 years later, there is another part of physics that we will understand, and it will explain black holes, or it will create another types of objects in the universe that can eat or or create or destroy information as well. So we don't know yet.
Yeah, definitely. That's why maybe he started with, I know it's kind of theoretical. Nobody knows, as you said.
Well,
So,
yes, yes, he started theoretical work, but eventually it was proved to be correct. Most of the theories don't need to be proved correct in nature, but that's why he is Einstein, right? That's why we know him very well now.
Yes.
He just made the calculations, and then he said, okay, the universe should work in this way. And yes, apparently universe worked in that way. If he wouldn't discover general relativity, possibly someone else could find out general relativity in the next few years. But because the physics was going toward that direction, somebody would
Yes.
find it. But there could be another physics that we have no idea right now is dominating the universe, and we don't know it yet.
It reminds me the Newton's quote, I'm on the top of the letters. So definitely it will develop, I think. We have
Yes.
one more question. Güney asks, can Blue Origin replace SpaceX position on NASA's ISS missions?
Well, yes and no. Anything can happen. A company can bankrupt. These things can happen. But right now it's hard. Blue Origin's rockets, even the Blue Origin is the first company or first commercial company who do the vertical landing. Did you know that? Everybody thinks that SpaceX did it first, but Blue Origin did the vertical landing 1 month before. I think it was 1 month before the SpaceX. So, but apparently they didn't spend enough money or enough energy on rockets at that specific time where SpaceX was growing much further. And yeah, I mean, Blue Origin is much smaller company right now comparing to SpaceX. On the other hand, Jeff Bezos is a billionaire. He can just say, okay, I want to spend, this much amount of my money on Blue Origin, and then, and I want to make it better than SpaceX. He can. But right now, SpaceX is the only American company that can send astronauts to the ISS right now.
Yeah.
There is New
Yes.
Glenn that Blue Origin is preparing right now. And well, they are working on it, but it will take time as well. Well, we don't know it yet. But right now, a proven spaceship is the Dragon capsule that can send astronauts to the ISS. I mean, just 2 days ago, actually 1 day or 2 days ago, new Axiom Space astronauts arrived to the International Space Station with the SpaceX's Dragon capsule. So it just works.
So it comes to my mind our next question. But before it, I want to ask, what do you think about Turkey's space studies? How do you think? How is the Turkish space future?
Turkish space future needs more people like you, and it only works with people, right? If you
Yeah.
don't have enough people, even though you have a lot of money, it doesn't work. It may work at some point. For example, United Arab Emirates has a lot of money, and they said, okay, we want to go to Mars, and their first Mars mission was like built by the United States and sent by, I think, the Japanese rocket. So it's like, if you have money and if you have a vision, then you can be in the right direction, but you still need a lot of people. Right now, for example, United Arab Emirates is building their teams inside the country. So even though they had great help from the United States to do to finish their Al Amal mission to Mars, but right now they have people to continue the operations of the spacecraft. And the other best thing is they have their vision. They say, okay, we are going to do this on Mars in the next 100 years. So they have kind of vision in there as well. So for Turkey or for any country, they need to put some money in it and then put some vision in it, so that young generation like you feel like, okay, there is a future in this field right now, and I can just go further. So if
Yeah.
you would not see there's a space policy in your country, Why would you want to study, space, space engineering, aerospace engineering, or astrophysics, right? You
Because
want to see the vision
yeah.
first.
Yeah, yeah. As you said, I think we have an endless field. If we don't have the chance to live in the world, we have also the chance in the space. So right now in the world, it's the most endless field for
Yes.
studies, for all the things. So that's why we need more people. For example, at METU, as you said, we have 200 electronic people, 200 mechanic people, but as aerospace, we have only 90 students per year. So it's also has to be more people in our university and in Turkey.
Yes, you're right. The number would increase when there is a vision in the country. If the country says, okay, we are going to go to Mars, and I don't know, we will have a Mars mission. You don't have to send humans to Mars. You can have a rover or an orbiter or whatever to Mars in 2030, 2035. It seems
Yes.
like too distant future, but there is a there is a plan. And to have this plan finished in a certain time, you need people. And as a young generation, you see this, this target, and then you would say, okay, I want to build that spacecraft, right?
Mm-hmm.
So if there is nothing, then you would say, okay, there is no future in here, so I just love, space. I just finish my education, and then find a country who does this kind of, work.
Yeah. Yeah.
That's
You're right.
why, yeah.
So I hope we will have more areas to
Yes.
work and to study of space. And I see some more questions. Lyrixium asks, is it possible to build a Death Star?
That star in the movie, or a star that is really dead? I think the movie, that star in the movie. Well, maybe it's possible. I don't know. It takes it, not in the century or the next century, I think. But a stellar death is, if you are really meaning a complete death of a star, it will take really, really, really long time, trillions years, which is called um, black dwarf. So normally stars create energy, right? And then
Yeah.
when the star dies, it will be converted to a neutron star, a white dwarf, or a black hole, right? So these are the three paths that a star can die. But there is still atoms in it that can create some energy, that can create some pressure, and that they will create pressure, and they will create pressure, very little, but in the end, it will take billions or trillions of years to have to have this energy finished completely. And
Yeah.
yeah, I mean, imagine the age of the universe is 13.8 billion years right now, and I'm talking about trillions of years, many trillions of years to really kill a star.
So I don't think it's possible to reborn a star because, as you said, it's a long period of consuming energy. So it doesn't seem
Well,
possible.
new stars are born from the dead stars.
Yeah.
Okay, but you need supernova explosions, and these supernova explosions are like creating a lot of material and then just explode the universe. The picture just behind you is that, it's a nebula, and from these nebulas, new stars are born. The problem is, 95% of the stars in the universe has been born already. So
Yeah.
we are almost at the end of, we are going toward the death of the universe now. So there will be only 5% of the new stars being born in the future. Yeah.
Okay. Thank you. And we have some more questions, so I have to choose. Barish has again a long question. If we manage to make faster and better spacecrafts to explore the universe, as the speed increases, the relative time that one feels will slow down. So can we actually go light year distances within a human lifetime, or can we go to our neighbor galaxy, Andromeda?
Well, there are two questions here. One of them is there is a speed limit, which is called speed of light. The speed of light is 300 kilometers per second, so you cannot go further than that. And even though you have a speed, or you have a speed close to the speed of light, you don't really go much further. It takes really long time. Even the nearest star takes like 4.3 years with the speed of light. So it takes really long time to go there. And to go to the nearby, there was a galaxy. Seriously, even though you have a speed of light spacecraft, it takes 2.5 million years to reach Andromeda. So the second question in here was human lifetime. No human lifetime could do that. But my idea is we don't stay as Homo sapiens in the next a few hundred years anyway. In the next a few hundred years, we will change to something else. I mean, there is evolution, and we actually accelerate the evolution because of the technology. We can change genes and everything in our bodies and everything. We can make the humans differently in the future. We are Homo sapiens right now. It just evolves up until this moment, but right now with the CRISPR, or with the gene therapies and everything, we can just change ourselves to stay under radiation or under harsh conditions, like cold temperature, warm temperature, or hot temperatures, or anything, and we can just stay. And can we just continue to be called Homo sapiens at that time? Maybe not. So a few hundred years later, humans as we know it may not be here anymore.
Yeah.
And they may go. For example, if we send Curiosity to Mars, we send the Curiosity to Mars, right? No problem. It just goes there and it just works. If we can create another robot that can stay, under the cosmic rays, that can be protected under the cosmic rays, or solar radiation and everything, and it just travels, many years, many years, and maybe we can be connected as a human. We can be connected to those machines as well, and then when these machines arrive there, we also arrive there as well. So it's called like transhumanism stuff. It's a long topic. I can talk hours on it, but yes, we may not stay as Homo sapiens anymore in the future, and we can go, and they can go to different stars. Maybe not galaxies, but stars.
Actually, I have a dream, and maybe we can build a smart house or smart home that enables us to stay longer in everywhere or in space, because as you said, we don't know whether we can survive in this world. So I guess we have to make more studies to live abroad the world.
Well, yes. Well, we evolved to this planet anyway, so that
Yeah,
we can only live here with our, we need, there's 20% of oxygen in the air, right?
yeah,
So if there is 23% oxygen, it doesn't work. If there is 17% of oxygen, it doesn't work too. So we are for this world. And it's not like we go to Mars or another planet, we can safely live there. No, it doesn't work that way. We are not evolved to that planet. Our bodies, our bodies are accustomed to this environment and everything, or the temperature and everything, and this is what makes us in this planet. But yes, for Mars, there is 96% of carbon dioxide. You need to be a
yeah.
tree to live there. Seriously.
Yes,
Seriously,
yes,
trees breathe carbon dioxide and give off oxygen, right?
yeah.
So
I
you
know,
need to be, yeah.
it's complicated, yeah, but it's nice to dream. So we have,
Well, you can be a tree in the
yeah.
future. No, I'm not saying you
No,
cannot be. You can
no,
be.
not being
You
tree.
will you will be a tree maybe 150 years later. I'm not sure about 100 years, but maybe 150 200 years later, you would breathe carbon dioxide and give off
Yeah,
oxygen, because maybe things would change. Some of the organs in our body may change by technology in the future, and we just imitate trees, and then we can live on Mars.
yeah.
This
Yes.
is also a possibility.
As we talked, Berat has a question. When will the universe end? He asks.
Oh,
Sorry, Berat.
this is
Yes.
this is a very long topic. We because it's a very long this is a very long time. We don't know yet, of course. There are different theories. There is a, heat death of the universe, big rip theories, big bounce theories, um, cyclic universe theories. We don't know which one the universe which theory will the universe will end. And right now, heat death theory is the most accepted one, but it may change in the future, maybe even tomorrow, with the new findings. With the heat death theory, the universe is just expands. It just cools down. As I was telling you, the black dwarf star,
Yeah.
the stars are also dies. It takes trillions of years, and then everything will be eaten by a black hole, and eventually the black holes are also dies. So it's a boring death, and it will take trillions of years. Even a standard black hole dies in 10 to the 100th year. Imagine 10 to the 100th year. Current age of the universe is 13.8 billion years. 10 to the 100 years, you just put hundreds, zeros,
Yeah.
and put years next to it, just to kill a black hole. And we are talking about the universe. Universe has time, don't worry. There is no when. It just goes all along.
Okay. IQ has a question. Thousands of satellites are used in Starlink project. How long will these satellites run? When this time is over, wouldn't that many satellites cause space pollution?
Yes, they are. They will, and they are right now. Right now, I think. Okay, let me check. How many Starlinks up and running right now? It was about 2000 something. I'm just checking the Wikipedia page because they oh they were actually up to date with the current number. Okay, they are not up to date right now. Oh, 2,335 Starlinks have been launched, with 2,110 still in orbit. Okay, so there are 2,000, almost 2,100 Starlinks are in orbit, but according to the SpaceX's filings on FCC, they want to send 42,000 Starlink satellites. And these satellites, especially the current ones, are very small satellites. I mean, small. It's not like CubeSat. It's still huge. It's like
Yeah.
250 kilogram satellites. But the next generation, the version 2, will be much, much, much bigger. So yeah, and they are actually waiting for the Starship to be finished, and it will create space pollution. Yes, if they crash, they will create space debris, and yes, they will create more pollution. But the problem is, SpaceX is not the only company who are sending this kind of constellations. There are a lot of other companies in another part of the world who wants to send more satellites into space, and they want to build constellations to do mobile telecommunication, or doing IoT support,
Yeah.
or many other things. There are a lot of different companies are building constellations. Even there is one in Turkey as well, in Ankara. So yes, there will be a lot of satellites in the future, and it will be hard to keep up with them. Actually, it's not our problem. It's the United States government's problem right now. They are actually following and tracking all the satellites and all the debris, which is bigger than 5 centimeters. So
Yeah.
if something is in space bigger than 5 centimeters, United States government follows them and tracks them almost every single day, like every 2 days, 2 or 3 days, and then find out its trajectory, its orbit, where it is right now and where it will be in the next few days. So yes, it's going to be a big problem.
Actually, we have visited TÜBİTAK Space Institute last Friday as AIT Ankara, and as you said, we saw the evolution of our satellites. They were like small to big. They're always
Yes.
going to be bigger and bigger, and
Yes.
it's America's problem, as you said.
Well, it's everybody's problem in the future. If there are, hundreds, a few 100,000 satellites in space, that means it will be hard to send new satellites in the future. Okay, space is big, but finding a nice orbit will become a problem. Right now, it's just like a bus service. SpaceX just sending the new satellites into orbit and then just drop them every 5 seconds, and then okay, this is your orbit. And in the future, it won't be happening that way anymore. There will be a lot
Yeah.
of new satellites, and there will be a lot of collisions, and every collision creates space debris, and that will create more problems.
Yeah. We have this question, and I guess it will be the last one because we have more questions, but I don't know how the time passed. It's so
Yeah.
fast. So I'm reading. Do you think water bears comes from other life forms, which means they are sent to the Earth on the purpose of experiment? What's your precision about this topic?
No, of course. Actually, on my YouTube channel, I have a almost 2 hour program about the water bears tardigrades, and they are not from different life forms. They have the similar characteristics of Earth life forms. So we are sure about that. They are just different. There are a lot. I mean, we think ourselves, different, but we, with the developing brain and everything. But no, these are just microscopic organisms. They can just stay in harsh conditions, but they are not extremophiles, by the way. They do not live in extreme conditions. They just stay in the extreme conditions. They are not like they don't enjoy being in the fire or in an Antarctic cold. They just it's like a normal bear, hibernation. They just hibernate. They just kind of hibernate themselves. You know, they just drop like almost 100%, 99% of water of them from them, and then they just close themselves like that, and then just wait for a normal condition comes back. So they still live in an environment like we like, but they don't die in harsh conditions as well. Yes, it's
Okay.
1 hour. Thank you very much.
So this question brings us to the end. It was so fun and entertaining speech. I'm so happy to meet you, and I guess our friends are also happy to meet you because we saw you in so many events in Turkey. I hope we will meet face to face next
Yes,
year
yes,
or
yes.
next
Sure,
semester.
sure, sure, sure, sure. Thank you very much.
So thank you so much. We are glad to host you here. I can give my words to Dilara, our moderator. Thank you so much. Have a nice day.
Thank you.
Thank you, Mr. Yıldız, for his speech. We have a half-hour break. At 5 p.m. UTC, Emre Havazlı from NASA will be with us with the subject of use of radar observation studies in Earth science. See you in the next section. Bye-bye.
Bye-bye.
Hello everyone, my name is Elif Güney. I am third year student at Aeronautical Engineering and Civil Engineering at Istanbul Technical University. I am also a fresh member of EUROAVIA Istanbul. Today, Mr. Havazlı with us. He is currently working as signal engineering at National Aeronautics and Space Administration. Thank you, Mr. Havazlı, for being with us. How are you today, and can you hear us clearly?
Yes, I can hear you clearly, and thank you for inviting me today. And I hope all the organization committee is also doing well, including yourself.
Great, thank you. At first, Mr. Havazlı is going to deliver a presentation on use of radar observation satellites in Earth science, and afterwards we are going to have a question and answer session with him. So you may write down your questions here in comment section.
I just want to make sure that you can hear me properly. Yes or no? Is that working? All right, perfect. So let me share my screen. Yeah, I hope everybody can see my presentation right now. So today I'm going to talk about use of radar observation satellites in Earth science, but we're going to maybe extend it to even further. So what you're looking at here is the 1993, July 1993 issue of Nature journal, and it goes with the title, it's the cover of the Nature journal, and the title is Image of an Earthquake. This is the first interferogram. This is the first imaging of an earthquake from space. And this was the data that was collected for Lander's earthquake in 1992, and two scientists from United States and France have collaborated in creating this figure, this image, and confirming that this is the image of an earthquake. So from 1993, we arrive in 2021, and this time not Nature but Science Journal has put Radar Revolution title on their cover page and said, "Satellite eyes watch Earth's subtle shifts." So here we can see the flooding that occurred in the Philippines, and this is a damage proxy map that was produced by JPL, the ARIA project, which I am also part of. So 1993 to 2021, the radar science has continued growing and finding itself even more applications. So the same article in 2021 was talking about the radar satellites as rulers of Earth and describing their uses as earthquakes, glaciers, infrastructure monitoring, volcanoes, water resources, and natural disasters. So when we look at the history of the radar satellites, we can see there were not that many radar satellites before 2017. And actually in 2018, the ISI launches the first commercial SAR satellite company. So currently there are startup companies around the world that are launching their own constellations and carrying out commercial SAR missions. Before that, there were only radar satellites, SAR satellites, I should say, synthetic aperture radar satellites that were developed by countries or space agencies that were funded by countries. So the most popular ones in the recent years are Sentinel-1A and Sentinel-1B, which were developed and operated by ESA, the European Space Agency, and they are providing radar images all over the Earth with a 6-day repeat orbit characteristic. And the ESA and the data is shared freely, free of charge for anyone who wants to use it. Currently, NISAR satellite is being developed in JPL, and it will provide land coverage of the whole Earth with an L-band data, and in some locations, such as India, It will also provide S-band data. And there are other satellite constellations that are currently active, such as ALOS-2, Cosmos SkyMed, ComSat-5, TerraSAR-X, TandemX from different countries, such as TerraSAR-X and TandemX are German, Cosmos SkyMed is Italian, and ALOS is Japanese. So, but if we want to talk about INSAR, what is INSAR? INSAR is the method that utilizes SAR acquisitions collected over an area of interest at different times. The phase difference between these two passes can provide us a millimeter level surface change detection in the satellite line of sight. And what does this mean? So here we are looking at the first pass of a satellite over an area. And this is what the satellite, the collected backscattering shows us. However, when we do a second pass over the same area, and if there's a change in the surface, the difference between the T1 and T2 are going to show us a quite different picture than what we see in a single SAR image. And once we do this multiple times, as the satellite continues flying over the same area over time and collecting more data, we can we can use all these figures, all these images, and create ourselves a history of deformation or history of surface change in the area and determine the deformation characteristics, which may be due to earthquakes or volcanoes or glaciers and so on. So to give an example of how an earthquake would look like, I would like to show you the earthquake that happened in Turkey, Sivrice, Elazığ, in 2020, the magnitude 6.8 earthquake. And this is Sentinel-1 data. And here we can see every color change from blue to red is a 2.8 centimeter displacement. So if we count all the changes from blue to red, we will need to add 2.8 centimeters. And you can see how strong and how quick these color changes occur closer to the fault, and how it goes to a less frequent as the distance increases. And this also shows us the distance that the earthquake has moved the surface. So this is what we call a wrapped interferogram. And as you can see, the scale goes from -pi to pi. And this is because of the nature of the radar phase. But we can unwrap this information and convert it to displacement. So what the fringes, the color changes in the previous slide meant, we can actually see it much clearer here. So we have a profile here that is crossing the fault in the middle, and that's perpendicular to the fault as well. And we can see here, I don't know if you can read it, but I'll read it for you. So the maximum, the profile starts from this point here and then ends over here. And once we reach the fault distance to be 0 over here, the total displacement is more than 60 centimeters around the fault, right over the fault. So this is the immediate displacement, the immediate proximity of the fault. Besides faults, we can also look at volcanoes, as we talked about it before. Here we are seeing Mount Etna, and we are seeing data collected between 1992 and 2001. And this is a really nice and useful animation that's showing us how the Earth and the mountains and everything we see around ourselves is actually not a constant, fixed and non-moving environment. They are actually very much alive, and they are continuously moving. It's just about how we can observe them. And here you see red. The red means 15 centimeter uplift, and the blue to purple is showing subsidence, and purple, the maximum reaches 10 centimeters of subsidence. So between 1992 and 2001, this was the movement of Mount Etna. And besides that, the INSAR has brought more, the Sentinel-1 data being freely available and INSAR being more and more useful. The new ways we discover to how to use INSAR, we are making it available to the public as well. So this is an image from the ARIA project that I am also part of, and this is the Tonga earthquake that happened in 2021. Sorry, not Tonga earthquake. It's the Tonga volcano eruption that actually tear apart the island itself. And here we can see the damage proxy map. Here we can see the phase, and here we can see how large the Sentinel-1 frame is compared to the island itself. But as we look closer, we can see how much damage there was there. But another example from Turkey, this is the Izmir earthquake in 2020, and this is again an ARIA product, the damage proxy map, and all the red dots here you see on this map are the estimated damaged buildings. Currently, I'm working in a project called Surface Water and Ocean Topography, the SWOT mission, and as of this week, there was 7 months and 10 days for its launch. So, SWOT is going to be working on detection and mapping and controlling of the change of water bodies on land and the ocean itself. So this way we will be able to use this information to track how we are using our water resources and how much the climate change is affecting the coastal cities and the ocean itself. So this is going to be a new technology that we are going to use radar over the ocean for the first time, and it's going to be simultaneously producing interferograms on board of the satellite, and unlike onboard satellite, unlike the previous generations of satellites that needed post-processing after the data collection. And another important mission to mention is NISAR. It's the NASA ISRO SAR mission and ISRO Indian Space Research Organization. So this is a collaboration between NASA and Indian Space Agency, and it will be launching in late 2023, if I'm not wrong, and it will collect a lot of data as well, like I mentioned before, over land. And it will be built with L-band instruments. So we know on the left that we can actually track Earth using satellite data, and we are doing all these things. But another interesting planet is Venus, that is providing us with similar habitat and similar nature with the Earth. How do we know that? We have limited observations of Venus that is showing us Venus may or may not have an active tectonics, but possibly had active tectonics in the past. And there are some possible landslide locations that has been mapped before. So if Venus is this geologically close to our planet, can we use a SAR mission there? And the answer is yes. Veritas, that is brought up by JPL, is Venus Emissivity, Radio Science, INSAR Topography, and Spectroscopy mission. And the science goals of this mission the science goals are actually what processes shape a rocky planet evolution, such as Venus or Earth. What geological processes are currently active on Venus? Can we detect an earthquake or a volcano explosion? Are there any earthquakes or volcano explosions on Venus? We will have an answer. Is there evidence of past or present water on Venus? This is, as we all know, water is very important for life on Earth, and water is very important for life in the universe. So finding evidence of water will be possible using this new SAR mission. But besides the Veritas mission, there is also the Envision mission that is being developed by ESA, and it will again be built by JPL for its radar and SAR instruments. And this way we are going to have two different missions on Venus that is going to be providing us information and insight how well we know ourselves and how well we know the universe. So thank you very much for inviting me, and I will be happy to take your questions. Hello?
Is there anyone who has questions? I think there is not. Special thanks to Mr. Havazlı for this enlightening presentation. And now I'm going to leave Dilara Yıldız to talk about this presentation. Thank you. Thank you for joining this presentation. We are about to end. It was really special. Thank you for all of you. Thank you.